Welcome back to my channel. Today we'll be going through some practice questions for the Tableau Desktop Specialist, and we'll be starting right off with question 1. When creating a data source, how can you add additional connections to different databases? A. From the drop-down menu of the current connection, select Edit Connection. B. From the Connections pane, select Add. C. From the Data menu, select New Data Source. D. From the File menu, select New. In option A, this option allows you to modify or edit the current connection, such as server details, changing credentials, or database settings. However, it does not allow you to add a new connection to a different database. In option B, there is no Add button in the Connections pane to add new data sources. The Connections pane shows existing connections for the active data source. In option C, the Data menu in Tableau Desktop allows you to add a new data source connecting to a different database or file, which will appear in the Data pane. Option D, selecting New from the File menu creates a new Tableau workbook, not a new connection to the data source in the existing workbook. So our correct answer here is option C. To add additional connections to different databases when creating a data source, you select from the Data menu and select New Data Source. Question 2. What types of data does a scatter plot require? A. One dimension added as a column mark. B. One measure and one dimension. C. Two measures. D. One measure, which is a date. For option A, dimensions can be added to a scatter plot for categorization or grouping, often using the column mark to differentiate categories. However, dimensions are not the primary data requirement for creating a scatter plot. In option B, a scatter plot typically does not require a dimension to function. It uses measures for the X and Y axis, and adding dimensions can enhance visualization, but they are not mandatory. For option C, a scatter plot primarily requires two measures, one for the X-axis and one for the Y-axis, to display the relationships between numerical values. Additional details are optional but not required. While in option D, a dates field, which is considered as a measure or discrete field in Tableau, can be used on one axis of the scatter plot, but this is not a requirement. Scatter plots require two numerical values or measures, but not exclusively a dates field. So out of the options we've been presented with, we'll be going with option C. A scatter plot requires two measures, one for the X-axis and one for the Y-axis, to display the relationships between numerical values. Question 3. What are two examples of a date value? For this, we'll be choosing two answers. A. January 1st, 1995. B. December. C. Wednesday. D. 2020-0501. Looking at option A, this is a complete date value which includes day, month, and year, and this can be recognized and used as a valid dates field in Tableau. Option B represents a month, but it is not a complete date value because it lacks a specific day or year. Same thing goes with option C. It just represents a day of the week, but it does not specify a specific date, so it is not considered a valid date value. Option D is a complete date value in the format year, month, date, and it can be used as a valid dates field in Tableau. So out of the options we've been presented with, we'll be going with options A and D. They are complete date values because they include the day, month, and year, and this is recognized and can be used as a valid date value in Tableau. Question 4. Which chart type would you typically use to compare parts of a whole across categories? A. Line charts. B. Pie charts. C. Scatter plots. D. Histogram. Line charts are used to show trends over time, and they are not suitable for comparing parts of a whole across categories. A pie chart is commonly used to compare parts of a whole across categories, and they visually represent how each category contributes to the total by showing segments or slices of a circle. Scatter plots are used to show relationships between two continuous variables, but they are not intended for comparing parts of a whole. A histogram is used to show the distribution of a single continuous variable, but it is not used for comparing parts of a whole. So the best answer here is option B, the pie chart. Each slice represents a proportion of the whole, and it makes it ideal for comparing relative sizes of a category. Question 5. To best improve the display of a scatter plot that has overlapping shapes, you should adjust the dash of the marks. A. Mark size. B. Mark borders. C. Color opacity. D. Color palette. Adjusting the mark size can help to reduce or increase the overlap, but it might not fully address visibility issues in cases where many points still overlap. This is not the best option, taking into consideration the question that we've been presented with. For option B, adding borders can make individual marks slightly easier to distinguish, but it does not effectively resolve overlapping issues. For option C, adjusting the opacity of the marks makes overlapping points partially transparent, and this will allow you to see areas where marks overlap more clearly and visualize density. In option D, changing the color palette might improve visual differentiation, but it won't solve the issue of overlapping marks. So, out of these options, we'll be going with option C. To improve a scatter plot with overlapping shapes, it is better to adjust the color opacity so that it will make the overlaps more visible. Question 6. Can you create a relationship between the account ID field in one table with the profile num field in a different table? A. Yes, it is possible to create a relationship between fields with different names. B. It will be possible, but only if both fields are textual. C. It will be possible, but only if both fields are numeric. D. No. Fields with different names cannot be in a relationship. In Tableau, relationships can be created between fields with different names as long as the data types of the fields match. So for instance, if both fields are either numeric or textual. When creating the relationship, you can manually map the fields in the relationship editor. Looking at option B, relationships can be created with numeric fields as well, not just the textual ones. Same thing applies for option C. Relationships are not limited to numeric fields. Textual fields can also be related. In option D, Tableau allows you to map fields with different names manually during the relationship setup. So we'll be going with option A here. It is actually possible to create a relationship between fields with different names, and this is done by manually mapping the fields in the relationship editor. Question 7. What are two characteristics of relationship? We'll be choosing two answers here. A. Relationships will query every table in a data model regardless of whether the fields are in the visualization. B. Relationships will query only the tables and fields needed to create a visualization. C. Relationships are only supported when using extracts. D. Relationships are aware automatically of the native level of detail of logical tables. In option A, relationships are optimized to query only the necessary tables and fields used in the visualization. This makes them more efficient compared to traditional joins. In option B, relationships allow Tableau to query data dynamically based on the fields and filters in the visualization. This ensures that unnecessary tables or fields are not queried, thereby improving performance. For option C, relationship works both Relationships work with both extracts and live connections, thereby providing flexibility depending on the data source and connection types. And in option D, relationships maintain the granularity of the data by respecting the native level of detail of logical tables. This helps to prevent issues like incorrect aggregation or duplicate data. So out of the options we've been presented with, the two characteristics of relationships are options B and D. Relationships allows Tableau to query data dynamically based on the fields and filters in the visualization. This ensures that unnecessary tables or fields are not queried, thereby improving performance. And also, relationships maintain the granularity of the data by respecting the native level of detail of logical tables, thereby preventing issues like incorrect aggregation or duplicate data. Question 8. You want to provide additional information when hovering over a field in the data pane as shown in the following exhibits. What should you configure for the field? A. An alias. B. A header label. C. A default comment. D. A hierarchy. An alias changes how the field name appears in the view, but it doesn't provide hover over descriptions. It is not used for adding comments or tooltips in the data plane. A header label is used to display the name of a field when it appears in a visualization or axis, but it is not used to add comments or tooltips. A default comment allows you to add a description for a field that will appear as a tooltip when you hover over the field in the data plane. And this matches the behavior that is shown in the exhibits we have. We can see that when the mouse hovers over that product name, it shows a comment showing us product name including company information. Looking at option D, a hierarchy is used to group related fields together for drill down functionality, but it doesn't allow you to provide tooltips or comments. So out of these options, the correct answer would be option C. Default comment allows you to add a description for a field that will appear as a tooltip when you hover over the field in the data pane. Question 9. Ben would like to break down his company sales by product category. He has all the data, but the chart does not show the individual colors. What should he do to create the colors? A. Right-click on the blue circle and choose colors. B. Select the pie chart icon in the Show Me area. C. Select the color icon in the Max card. D. Select the multi-circle icon in the Show Me area. In the provided screenshots, we can see the chart is displayed as a single blue circle. To break the sales down by category and display individual segments in different colors, Ben would need to select the pie chart icon from the Show Me area on the right. So by doing this, the action will convert the chart into a pie chart where all the categories will be broken down, and Tableau will automatically assign colors to each segment. So all Ben needs to do is to select the pie chart icon in the Show Me area by the right. So our answer is option B. Question 10. What are 3 reasons to use joins instead of relationships? We'll be choosing 3 answers from the options. A. You need to use a specific join type. B. You need to create an extract that will have multiple tables. C. You need to use row-level security. D. You need to use a data model that supports shared dimensions. In option A, joins give you full control over the type of join that will be necessary depending on how you need to combine the data. However, relationships do not support specific join types directly. So we have different types of joins. We have the inner join, left join, right join, and full outer join. Looking at option B, when creating extracts, especially if you're combining multiple tables into a single table for better performance, joins are typically used. Relationships are more appropriate for logical separation of tables, but it might not work as efficiently when combined into one physical extract. In option C, row-level security can be applied to data sources and often works more effectively with joins because the data is combined into a single table, and security filters can be applied more easily. In option D, shared dimensions are a key feature of relationships because they allow you to combine multiple tables without requiring them to be physically joined, thereby keeping the model more flexible and easier to manage. But if we take a look at the question, it's asking for the 3 reasons why joins are used instead of relationships. So looking at the options we've been presented with, the 3 reasons would be options A, B, and C. Joins give you full control over the type of join used when combining multiple tables into one, and row-level security can be applied to data sources. Question 11. How can you access options to apply bold formatting to an axis in the view? A. Select text on the marks card. B. Select field labels on the Format menu. C. Right-click on the field and select Format. D. Right-click on the axis. Option A is related to formatting the marks in the visualization, but not the axis. In option B, field tables are for formatting field labels, but not for the axis itself. In option C, right-clicking on the field and selecting Format would open up the formatting options for the field itself, but not the axis. To apply bold formatting to an axis in Tableau, you can simply right-click on the axis in the field and select Format. This will open the formatting options where you can adjust the font settings, including making the text bold. So we'll be going with option D. Right-clicking on the axis is the most direct and appropriate method to access axis formatting options. Question 12. With the marks card drop-down menu set to automatic, a line chart will be created whenever you place what on the rows shelf and the columns shelf. A. Measures on one shelf and a date dimension on the other. B. 0 or more dimensions on one shelf and 2 or more measures on the other. C. 0 or more measures on one shelf and 2 or more dimensions on the other. D. A date dimension followed by a continuous measure on one shelf. In Tableau, when the marks card drop-down menu is set to automatic, a line chart is created when you place measures on one shelf, which is usually the rows shelf, and you place a date dimension on the other shelf, which is the column shelf. So the date dimension could either be ship date or other dates, while the measure can be, let's say, sales and profits. So this combination of measure and a date dimension is used to visualize trends over time. Remember, line charts are used to show trends. So the combination of a measure on one shelf and a date dimension on the other is used to visualize trends over time. And this is why Tableau defaults to a line chart when you combine measures and a date dimension. So out of all the options we've been given, the answer would be option A. In option B, using 0 or more dimensions on one shelf and 2 measures on the other would result in a different type of visualization. It will usually be a scatter plot rather than a line chart. If you use 0 or more measures on one shelf and 2 dimensions on the other, it could lead to a variety of chart types, but not a line chart. The same thing for option D, using a date dimension followed by a continuous measure on one shelf would also produce a line chart, but the phrasing of option A that we have is more typical and precise when referring to how Tableau automatically generates a line chart. Remember, sometimes the options that you've been given might sound similar, but you have to read the questions, read all the options, and select the one that best suits the question being asked. So out of the options, option A best suits the question being asked. Question 13. What is created by a calculated field that has a formula of sum sales over sum profits? A measure. B, a dimension. C, a set. D, a parameter. In Tableau, a calculated field is a new field that is created by applying a formula or an expression to one or more existing fields. So, for instance, the formula sales over profits performs a calculation that aggregates the sales and profit fields and divides the sum of sales by the sum of profits. Since the formula results in an aggregate value that represents a quantitative measure, the calculated field will be treated as a measure. In option B, dimensions are qualitative fields. So dimensions could be, for instance, customer name or product category. And these are typically used to slice or categorize data. But for a formula like sum sales over sum profits, it will result in a numerical value and not a categorical one. So option B is incorrect. A set is a custom field used to group data based on specific conditions, but it is not used. It is not a calculated field that is produced in this case. So option C is incorrect as well. A parameter is a dynamic input field that can be used in calculations, filters, or as part of a formula. It is not the output of the formula itself. So option D is also incorrect. Our answer here is option A measure. Question 14. What type of join is used in Tableau when you combine two data sources with different levels of details but the same fields? A, inner join. B, left join. C, full outer join. D, self join. An inner join only includes rows where there is a matching value in both data sources. If the data sources have different levels of details, some records from the left source might be excluded if there is no match in the right source. This would reduce the data set, and it is not ideal when you want to retain all the rows from the left data source. When combining two data sources with different levels of detail but the same fields in Tableau, a left join is typically used. This join keeps all the rows from the left data source and adds matching rows from the right data source. In a case where there is no match in the right data source, the results will still include the rows from the left source with null values for the fields from the right data source. In option C, full outer join includes all rows from both data sources, matching where possible and filling with nulls where there is no match. While this might seem useful, it is not as efficient when you want to prioritize the left data source and only pull in matching data from the right source. In option D, a self-join is used when joining a table to itself, and this is not applicable in the scenario we have here. So, we'll begin with option B here. When dealing with data sources that have different levels of detail, you often want to retain all records from the primary data source and only include matching data from the secondary data source. This is true when the left data source has more detailed data and you want to preserve it. So that's why option B is the best answer for this question. Question 15. Which option should you use to invert the color intensity of a quantitative range? A, border. B, reversed. C, opacity. D, stepped color. The border option refers to adding borders around marks or elements in a visualization. It has nothing to do with the color intensity or to reverse the color scale. In Tableau, when you want to invert the color intensity of a quantitative range, you can use the reversed option. This option allows you to flip the color gradient so higher values are displayed in the color associated with lower values and vice versa. In option C, opacity controls the transparency of the marks, but it doesn't alter the color intensity or reverse it. And in option D, the stepped color option divides the color scale into discrete steps, but it doesn't invert the color intensity. So our answer here is option B. The reversed option allows you to flip the color gradient so that the higher values are displayed in the color associated with the lower values and vice versa. Question 16. Which two filter modes can you use with dimension filter? So we'll be choosing two answers from the options. A, range of values. B, at most. C, wildcard match. D, multiple values or drop down. For this, we'll be going with options C and D. In the wildcard match filter mode, it allows you to filter data based on patterns or substrings. For instance, you can filter all entries that starts with A or ends with X using wildcard characters like the asterisk for any characters or the question mark for a single character. The multiple values filter mode enables you to select multiple values from a list in a drop-down menu. And this is commonly used when you want to choose more than one dimension member for the filter. So that's why these are the two best answers, the two filter modes that you can use with dimension filters. Question 17. The option to create bins is available for which type of field? A, Boolean. B, numeric. C, date. D, string. Boolean fields contains only two values, which is either true or false, so they are not suitable for binning. Bins are typically created for numeric fields in Tableau, and this allows you to group continuous numeric data into discrete ranges or bins. For instance, you can create bins to group sales figures into ranges such as from $0 to $100 or even age groups. In option C, although you can create date ranges, bins are usually created for numeric values, not directly for date fields. And in option D, string fields represent text and cannot be binned because they do not have any numeric continuity to group into ranges. So our answer here is option B. As we can see in the screenshots we have, an age bin was created to group figures into ranges. So for instance, in the age bin, if it were expanded, you would have seen something like from 18 to 25, from 26 to 30. So something like that. Question 18. You need to display the complete list of potential data connections when you connect to a server. What action should you perform? A. Select connecting to data. B. Select more under to a file. C. Select more under to a server. D. Select file on the menu and then select new. For this, we'll be going with option C. When connecting to a server in Tableau, the To a Server section provides various options for the different types of server connections. So you have connections like SQL Server, MySQL, Google Analytics. To view the complete list of potential data connections, you can click More under the To a Server section to see the additional connection types that you can use. Question 19. Which two types of aggregations can be applied to string fields? For this, we'll be choosing two answers. A. Minimum. B. Sum. C. Average. D. Count distinct. The two types of aggregations that can be applied to string fields in Tableau are A. Minimum. So you can apply a minimum aggregation to string fields to get the lexicographically smallest string value. For instance, to get the first alphabet, alphabetically. In options B and C, sum and average are not valid aggregations for string fields. These aggregations are typically used for numerical data, and Tableau will not allow you to apply them to string fields. Looking at option D, you can use the count distinct to count the number of unique strings in a field. So out of all these options, the two types of aggregations that can be applied to string fields is options A and D, minimum and count distinct. Question 20. How is a TWBX file different from a TDE file? A. A TWBX file does not store the data. B. A TWBX file stores the visualization as well. C. A TWBX file stores a connection to another workbook. D. A TWBX file does not store extracted data. A TWBX file includes the visualization or the workbook as well as the data, while a TDE file contains only the extracted data. So, in a TWBX file, it is a packaged file that contains both the Tableau workbook, any extracted data, and any external files such as images or custom shapes. This format is useful for sharing visualization with others because it contains everything needed to open and view the workbook. The TDE file is only the data extract itself, so it does not include any visualizations or workbook. It is a Tableau data storage format that allows for optimized querying and performance. So the major difference of a TWBX file from a TDE file is that the TWBX file stores the visualization as well as other extracted data and any external files. We have come to the end of the video for the Tableau Desktop Specialist Certification exam. Don't forget to like, comment and share, and also hit the subscribe button so that you'll be informed when our next informative video will drop. Thank you for watching, and I'll see you in the next video.